see, we got the wings off in the wing cradle. The chemical hopper started leaking and we had to do some field repairs. So I'm just pan over here and show you this bird. Okay, this is an AgCat biplane, purpose-built restricted use agriculture aircraft. This one started leaking, so we had to do some repairs, and that meant taking the wings off and pulling the tank. As you can see, we had some treatments to do to the chrome moly tubing, so it has been sandblasted, taken down to bare metal, and it's in the process of being put back together, as you can see. And the chrome moly tubes are treated with a chemical resistant urethane, single stage urethane, made by AirTech Coatings. Made a really nice job. You can see the tubes are just fantastic shape. So while the fuselage here is being put together, I figured I'd show you some fiberglass work. Let me go up here to the front of the hangar where I got a little bit of a mess set up. This is just a field repair of a chemical hopper. I got my little table set up here, just a temporary piece of glass, an old end table or something. I forget where I got this glass. But this works out really good for me if I want to wet out some layups. I can put saran wrap down there, put my layup down, wet it out with the resin, put a piece of plastic on there, and pre-wet out my layups for the repair if I choose to do that. Let me make a little bit of a room here. Okay, I'm going to pan out a little bit here so you can see. So overnight it got down to about 40 degrees, something like that, and you can see I left halogen light set up on the tank. That was just to keep temperature up at the tank. This epoxy that I'm using, it needs to kick off, it needs to reach temperature. I think they call it peak exotherm, if I remember properly from my days of going back in school. So I've already did one patch here. There's a couple bolt holes somebody put in the tank to stop leaks, and there was a big fill pipe coming in here that had blown out and actually cracked the fiberglass and did a lot of damage. So the first thing was to fill these holes. I'll back you up a few steps later, but as far as the repair goes, fill these holes with microfibers and resin or epoxy. And then I had some mold release on a piece of aluminum clamped here, and I did my layup from the inside. You can see the mold release with a piece of aluminum left this surface relatively flat and very clean, not full of pinholes or air holes or voids. So it's a nice structural repair. And let me flip it over and I'll show you the inside of the tank. Okay. This here is the repair. You see the outline of the hole that was in it. This is approximately, I think about 10 layups, 10 layers of bid, coarse woven glass with epoxy. And the way that you would properly do this, you take the thickness of the material and you'd scarf out a taper about a 10-to-1 slope. So this is probably scarfed out, I don't know, maybe 2.5, 3 inches around every one of these repairs. And let me flip the phone over and I'll show you on this bottom one. So I let this set up, and then I flipped the tank, and I did the same thing here. There's a bolt hole here and a bolt hole here where a previous mechanic did a temporary patch. Shoot, might have been me, I don't remember. But somebody did a temporary patch to get the machine through the season. Put a little bit of sealant in there, drew out the spot that was bad, and put a bolt in there. So this is my back plate. This has, you can see this white, almost waxy stuff. This is just a mold release, and I just used a simple Canuba wax. Works really well. and I have a piece of angle clamped in place. You can see my piece of angle here. Take the clamp off the other side. So this piece of aluminum with the mold release on it just gave me a nice back plate for this repair. If I can get a picture of the bottom side, I'll flip the tank. That may have got it. I'll have to review the video later to see. But where these holes were, I used a microfiber slurry, if you will, epoxy with milled fibers blended into it to fill the hole initially, and then I did about 10 layups of coarse bid on top of it, small, you know, sequentially getting bigger layers. And now I'll trim all this up this morning. You can see the layup. Get a close up here. The layups really nice. No dry spots in the weave. Everything's wetted out just as it should be. No air bubbles. So by sizing the layups and by using the milled fibers in the beginning to fill any voids and make the layup area transition smoother, we get a nice strong layup. Okay, here's the reason why we're doing this repair. This flange was glassed to the bottom of this tank, just like so. This flange holds the apparatus onto the bottom of the aircraft for the spray system. Now, two things were wrong with this layup initially, in my opinion. I'm sure there's going to be several opinions on that one way or the other, but first thing was this aluminum is very susceptible to corrosion with the chemicals that are contained and often carried in this tank. Secondly, this aluminum flange was primed with a zinc-based primer. They primed it, they slid it up onto the hopper just like this, and then somebody used actually fiberglass matting and a polyester resin to wet out this and just attach this flange to the tank. Nice thing is it made it very easy to cut the flange off and remove it. The bad thing is this flange was never bonded to the tank. So chemical on the inside, even though it was glued on the outside here where my left hand is, just like so, chemical on the inside could get underneath this lip and go up in between the layers. And once it touched this aluminum, it just started festering and growing and oxidizing. And as you can see, the condition of this aluminum is very poor. You can see here where the chemical was going up in between there. So in my opinion, this was a very poor design. However, this was assembled. And you can see the remnants of a pipe that was here. That's going to be eliminated and changed. That's why I had to fill this. This was cracked up and broken anyhow, so I had to repair it. But the new flange we have does not have this relief for a pipe, so we're going to change that configuration. But let me throw this outside. This is junk, and I'll grab the new one. Okay, this is the new flange. As you can see, it doesn't have that same provision for the fill pipe as the old one did. And this one is going to slide up on there just like so. It's going to make a very nice installation. Now, what I'm going to do differently is I'm going to use standard glassing techniques, and we're actually going to bond this aluminum flange to this fiberglass. I'm going to mechanically etch this, probably a 36-40 grit sandpaper, put a nice etch on this on the inside, prepare this surface, and I'm actually going to use milled fibers and epoxy and slurry this whole opening. When we slide this flange up on there, this flange will actually be bonded to this. Let me just hold this up here temporarily. We'll have to do some more fitting. Just for purposes of explaining to you my plans. Once I have this fitted and slid up on here, this inside surface and this surface of the tank will be bonded together. I can screed off the resin that oozes out, any number of things, and once it's up on here, then I can fill these holes with some microfibers and epoxy, and then I can do a layup over top of this to further reinforce it. Basically, we're going to treat this as a hard point. Any other kind of standard fiberglass work where you glass in a hard point, basically that's what we're going to use here. We're going to use that same principle. We're going to pretend that this is a hard point, and we're going to glass it in. Because essentially it is a hard point. This is where the sump and the spray apparatus bolts. It hangs off of this. So this effectively is a hard point. Let me get set up here, and I'll turn the camera back on, and I'll start recording once I start doing some actual fiberglass work. Show you something here. The previous repair is actually delaminated. It was a pretty shitty repair. It's actually not making it bad to prep for the new layup, but you can actually see the old repair right here is actually delaminated. It's actually delaminating from the original mold. This original mold's in good shape, but whoever used this fiberglass mat and polyester didn't even bond it to the original mold. So I'm simply taking my grinder and cutting this back, getting rid of all this delaminated layer, all this thick crap. They just kept on stacking it on top of each other. But this base coat was never bonded to the original fiberglass. So it didn't matter how much of this shit they stuck on top, this repair was never going to last. So I'm just going to follow this delaminated layer, cut all this off all the way around. There's no sense in recording all of this, as it's just more of the same, just a lot of grinding. So once I get this stripped off, I'm going to save a little bit of battery, save a little bit of recording space. I'll set the camera back up and we'll get back to recording. Okay, this is real important. There's some places where this polyester, this fiberglass mat, is almost an inch thick. You can see right along here where it's delaminated. You can actually get to see that fiberglass there. It's not even wet. Same thing here. This fiberglass was never wetted out. So what's important about this, and this is for aviation, I don't care about boats, don't know much about boats, but for aviation purposes, it doesn't matter how thick you pile the stuff on top. If you don't bond it to the subsurface, it's always going to delaminate. You're never going to get a bonded structure. This should never delaminate like this. This should never be dry fibers in between layers. Up in this corner here, I've been grinding on this. There's a whole flap here where it's completely delaminated. You can see the dry fibers up into this corner. Okay? That should never happen in a proper layup. And just piling stuff on top, just putting stuff layer after layer after layer will never fix that. The whole thing will just eventually delaminate and come off. You don't need this much material on top of it. 3 or 4 layers of bi-directional bid, it'd be plenty to bond this flange onto this tank. All this fiberglass mat and polyester, couple things. Number one, fiberglass mat should never be used on epoxy. Fiberglass mat should never be used with epoxy resin. Fiberglass mat has styrene in it that holds it together. It's designed to be used with polyester resins, stuff that you can buy at Home Depot and, you know, all the box stores, the Bondo brand stuff. That's polyester resins. The polyester dissolves the styrene that holds this mat together and makes it a decent repair for certain things. It's not structural, it's not for aviation. What we're going to use here to repair this is going to be an S-glass, okay, a bi-directional weaved S-glass. And we're going to use epoxy resins. So this side is fairly well prepped. As you can see, I got 3 more sides. I got a lot more work to do, and I'm going to end up cutting all this delamination out.